You must have had that daydream at least once. If you could time travel, would you go into the distant past, or would you go far into the future?
It'd be fun to walk around with dinosaurs.
I would travel to the future, all the way to the very end.
But Ron Mallett is different.
Now, according to my calculations,
He thinks he already knows how to build a time machine.
I think of myself as just being an ordinary person with a passion. And my passion is the possibility of time travel.
Get ready, this is some pretty weird science.
According to my calculations, the space inside this should actually become twisted.
But Ron's quest doesn't start here.
It's so fucking childish.
It begins when he was just 10.
My father was an incredible person. For me, the sun rose and set on him. And then it was all taken away, suddenly.
When Ron's father died, he became obsessed with the idea of time travel, dreaming of one day building a time machine to go back in time and save his dad.
I would say, Dad, two things. I love you and stop smoking.
It obviously sounds pretty out there, but time is truly mind-bending. This is how some of the world's most intelligent people try to explain time.
So what is time? So time is...
That's an excellent question.
Time is the change of... so clearly... It's difficult, yeah?
Yeah, it's really difficult. And if even trying to explain time can stump some of the world's greatest minds, then it's probably worth at least asking, is time travel possible? Yeah, it is. Time travel is not only possible, but we've already done it, and you've done it too. Every time that you've been in a plane, a train, a car, if you've run really fast, that is because that time is not absolute, it is warped by velocity and gravity.
3, 2, 1.
So here's a way to wrap your head around that.
Ignition and liftoff of the Space Shuttle Endeavour, extending our reach.
This is Peggy Whiston, the first female commander of the International Space Station. She spent a lot of time in space. 665 days to be precise. And here's the thing, because of all the time she spent up there, she's literally younger than she would have been if she stayed on Earth.
3 new residents headed for the International Space Station.
This is because of something called time dilation, which Einstein discovered in his theory of special relativity. It basically says that time is different for different observers, and that it can be warped by velocity and gravitational potential. So two clocks run at different speeds. If, for example, you are stood still and your friend is on a high-speed train, then because your friend is travelling at a higher velocity, that means that their clock is slowed down compared to yours. This applies to Peggy too. She spent so much time in orbit, travelling at a speed of 7.66 kilometers per second, that she's actually younger than she would have been had she stayed here on Earth. Okay, only by 0.02 seconds, but this is a real example of time travel in action. And what if she'd been traveling even faster? It's these weird properties of time that have excited the imaginations of would-be time travelers ever since Einstein announced his theory of special relativity, including Ron Mallett. And he claims to know how to do it. So, how do you build a time machine? This is Ron's prototype for his time machine. His idea is to use Einstein's theory of general relativity to twist the very fabric of space-time using light, or lasers to be precise.
In Einstein's general theory of relativity, space acts like a medium, sort of a fabric, and that fabric can be altered by using matter or energy. This device is a representation of the equations that I found solving Einstein's equations for gravity. I'm going to turn the device on and bring up the voltage. Then we'll use vapor from dry ice to make the beams visible. Now you can see the beams as they're scattering off of the vapor. And you can't see, of course, that the light beam is moving around, and this creates what's known as a circulating beam of light. Now, according to my calculations, the space inside this should actually become twisted.
Okay, pause. So Ron's thinking is that if gravity can affect time and light can affect gravity, why not combine those ideas and use light to affect time? That's why he's got these laser beams. Ron suggests that if you can use those laser beams to twist space-time strongly enough, then you could travel back into the past.
This equation says if you increase the intensity enough, then you actually can cause time to be twisted. And what this means is that if this is a timeline that we all live along, this represents the past, the present, and the future. And we're all carried along this river of time from the past, the present, to the future. Now, the thing is that if space is being twisted strongly enough, then what's going to happen is that this timeline, this linear timeline, is going to twist it into a loop. So if time now all of a sudden becomes a loop, that means that this allows us for the possibility of traveling back into the past.
So you might be thinking, well, why don't we have a time machine yet? And there are a few reasons as to why. So first of all, Ron says that we need vast amounts of energy, and to go with it, vast amounts of money, which so far no one has yet been willing to foot the bill. But there are some people who have even bigger problems with it. The experiment might need to be the size of the universe for it to actually work, or you need as much energy as would be required to form a black hole, or that the equations don't even work with our particular universe. So just small problems then. And even if everything did work, there's still one problem for Ron, in that you'd only ever be able to go back in time to the point in which you turned on the machine. So to conclude, wait, got a bit more time? Okay, if that wasn't mind-bending enough, try this one for size. The current generally accepted view in terms of how to think of time is that the universe is an unchanging block of space-time, that there's no past, present, or future, that they all just coexist simultaneously. And this is known as the block universe model.
Most notably, what's important about the model is the idea that...
Wait, hold on. Can we just take a second to appreciate the fact that the center for time is a place that exists? Okay, good. Philosopher Christy Miller works there.
What's important about the model is the idea that the past, present and future are all equally real. So you can think of everything that ever did exist, does exist or will exist as all somehow being out there in space-time. So the dinosaurs are all out there somewhere in the past doing dinosaur stuff. We're all here now, and all of the future is all out there somewhere in space-time too. One way of thinking about this model is that other places in time are just like other places in space. So just as we are here in Sydney, but there's other people located in Singapore and London, and those places are perfectly real, it's just that we aren't at them.
Okay, so clearly we can't even fully agree on how to conceptualize time. There are still intense disagreements about whether or not time even flows from one moment to the next. But we can agree that building a functioning time machine is still tantalizingly out of reach. But maybe it's just a matter of